Yeah, because I remember the first one was like simplify, solve something, and I was like,
we good, we good.
What else?
I mean, what was that?
That's it. That's it. Mhm. The rational expressions, the fractions, adding, subtracting, multiplying, solving the equations. This thing is doing that. Yeah. The fractions. Yeah, that thing. Yeah. Yeah.
What's that called?
Rational expressions, yeah. So any questions? Okay.
Factoring of the rational expression,
Mhm.
solving for X.
Yeah, that's the equations. Yeah, go ahead. 3 over x, like this? X plus 14, like that? All right, that's not bad. So anytime you have a whole number, right, you put that over 1, just like that, right? After that, LCD. What's the LCD here? No. All right, so I heard x plus 14. What else? And x, right? Very good. So that whole thing is the LCD, right? Now, in the first term, the 3 over x, I have an x in the denominator, right? I want to get it to look like this, x times x plus 14. So what is it missing? Yeah. Right? So I'm going to multiply this by x plus 14. But here's the thing, what I do to the bottom, I got to do to the top, right? This is x plus 14. I have a 1 right here, but I want it to look like the x plus 14 times x. So what am I going to multiply that by? Everything, right? Yeah. So that's going to be the x times the x plus 14. What I do to the bottom, I do to the top, right? The x and the x plus 14. Over here, I have an x plus 14. So what am I missing? The x, right? So I'm gonna multiply this by x, but what I do to the bottom, I gotta do to the top. Right. It's gonna be x squared. So what's happening now? Because I have an equal sign, right? So this is the rational equations. Because I have an equal sign, just working with the numerator. So this is gonna be what? 3 times x plus 14 plus 11, technically by times x plus 14, equal to 11x times x, right?
Oh, wait, what was that go for X?
No, because of the equal sign, I can forget about the denominator, right? Just working with the numerator here. After this, distribute, combine like terms, all that good stuff, right? So this is gonna be like this. So this is gonna be what, 3x plus, oh Lord, what's 14 times 3? 42, all right. And then we already know 11 times x is 11x. Then we're just gonna distribute that. So what do I have? I have plus 11x squared plus, what's 14 times 11? 114? It is? I don't even know. One 154, okay. So 154x is equal to what? 11x squared, right? After this, what do we want to do? Combine like terms, right? So what do I have? I have 11x squared plus 3x plus 154x is 157x, I believe, right? Plus, and then the 42, right? And then that equals the 11x squared, right? Now I want to solve for x, right? So I'm going to subtract 11x from over here, 11x squared, excuse me. But what I do to one side, I have to do to the other, right? So now what do I have? I have 157x plus 42 is equal to 0, right? And then what do I do after that? Subtract 42. What I do to one side, I do to the other. So now I have 157x plus 42 is equal to 0, right? And then what do I do after that? Subtract 42. What I do to one side, I do to the other. So now I have 157x is equal to negative 42. Divide by 157 to get x by itself. What you do to one side, you do to the other. This is my answer. Negative 42 over 157. Now remember, with the rational expressions, you're supposed to check your answer, right? Because what if it's like wrong? If it's right, you good. What if it's wrong? Yeah. So
This is adding rational expression.
solving rational expressions. Yeah. The difference, the equal sign. Yeah. So an easy way to do it if you don't feel like doing all that checking work, right? Check the LCD, right? So we know that the LCD is x times x plus 14, right? If you were to plug in this into the LCD, right? So negative 42 over 157 times negative 42 over 157 plus 14. If you plug that into the LCD, right? I'm not even asking you for an answer. Is this answer gonna be 0? Just look at it. Right? It's not gonna be 0, right? Just based off of that, you know that this is the right answer. You do it like that. Now, if it turned at 0, now we gotta have another conversation. Like that means this is not a right answer. It's an extraneous solution, right? So that's another way you could do it.
So if I take everything to LCD, just go by like certain after you simplify it.
Yeah, just check it, you know? If you don't check it and the answer is right, good for you, you know? But like if you don't check it and the answer is wrong, you know, same thing.
Can I be like a trick question?
All the questions like that. Huh? Zoom out, got you. All right, that's everything. Okay. So yeah, the test is just on the chapter 6, chapter 7 stuff. Nothing from yesterday. Yesterday was type fun though, I'm not gonna lie.
Oh, it's follow the problem. This is the rational. 11x.
Yeah. Once you see an equal sign, it's an equation.
Go back up. I think you did the.
No, this is the top right here. So Theo, everybody finished the test. They said it was easy, you know, like yeah.
You get points on being late.
Wait, let me catch up with you 1 second. All right, 6x to the third.
Negative 6x.
Like this? 3x to the third. That's it? Oh, it's not bad. So this is simplifying the rational expression, right? All you gotta do, factor the top, factor the bottom, cross out the like terms, and that's it, right? So in the numerator, what's the greatest common factor there? 6x, right? So I'm factoring out a 6x, so what's left over? X squared minus Not 6, 1, right? There we go. All over, right? And what's the greatest common factor in the denominator? Exactly, right? And what's left over? Plus 1, very good. But now that's a difference of two perfect squares right there, right? Up top, so we could factor that. So what's that gonna become? X plus 1, X minus 1, very good. And after that, just cross out the like terms, right? We have plus 1 here, plus 1 here, 6. Let me see, 3 goes into 6 once, and 3 goes into 6, excuse me. Let me say that again. 3 goes into 3 once, and 3 goes into 6 2 times, right? And then we could cross out this X with the square. So what's left over? I have 2 times X minus 1 over, damn, nothing, just X. X. I cross out the square, not the X. Yeah. So basically, think of it like this. There's 2 X's on the bottom, right? So I'm crossing out one of them. So it leaves back 1. Yeah. And that's it. Yeah. Right. That's the whole thing. You're welcome. Yeah, let me say it one more time. Pantry tomorrow, right? The link to sign up for it is in yesterday's announcement. You might want to take a look. Hold up. Let me catch up with you. I'm gonna switch. All right, so I heard 4x squared. It's x minus 5. Okay. X cubed. X squared. So in parentheses like this? Yeah. Oh wait, sorry. So like this?
Just like a dot.
Next to the x squared? Like this?
It's multiplied by.
Oh, I see what you mean, like this.
Yeah, like that.
Got you. Okay, got you.
And then it's X. Over. All right, this is not bad, right? All you have to do here, just factor each one, cross out the like terms, all right? So 4x squared plus x minus 5, what do we think that is? It could be either or. Let's do the AC method on that one. A times C is equal to 4 times negative 5. So what is that? Negative 20. And my B term is 1, right? So now I need 2 numbers that when I multiply will give me a negative 20. When I add them together, give me a positive 1. What are they? 5 and 4, right? So 5 times negative 4, that's a negative 20. And 5 plus negative 4, that's the 1, right? So rewrite this. I have 4x squared, but instead of the plus x, I'm gonna have plus 5x minus 4x minus 5. Let's group these together. Greatest common factor on the left-hand group is gonna be what? X, right? And that's gonna leave back what? 4x plus 5. What about this right-hand group over here, the negative 4x minus 5? What is the greatest common factor? Negative x, close.
-1, right? So what's left over? Mhm. 4, no, +5, right? There you go. Because remember, it's like you're dividing by -1, like you're divided by -1, right? So now greatest common factor again, 4x plus 5, and excuse me, plus 5. And then we have the x minus 1 left on the outside, right? So that's the fact of the numerator for this, all right? Not bad. So we have 4x plus 5, x minus 1 over, what's the fact of the denominator here? Right here. Say it. What is it? No, x squared, right? So I heard an x squared, and what else? What's left over? X what? You're right. X minus 1, right? Times. What about the numerator over here? Hmm. Okay, and what's left over? Good. X plus 2. All right, denominator. Oh, this is different. All right, so let's do AC method on that. We'll do it on the side over here. So A times C is equal to, I think, 4 times 10. 8 and 5, okay. Positive, yep. So that's 40. And then B is 13. All right, so 8 and 5, yep. 40 and 8 plus 5, 13, right? So now we're gonna rewrite this 4x squared plus 8x plus 5x. Hold on, plus 10. We're gonna group these together, right? Left-hand group. Greatest common factor is what? 4x, very good. What does that leave behind? Uh-huh. Plus 2, good. What about the right-hand group? Positive 5, good. What's left over? X plus 2, very good. Greatest common factor again, I have x plus 2. And it leaves back 4x plus 5, all right? Let's write that in over here. I got x plus 2, 4x plus 5. All right, so now that you have everything factored, right? Right, cross out the like terms. So I got the 4x plus 5, x minus 1, x plus 2. I have 1x here and a square here. So what's my answer? 1 over x. And that's it. So that's not bad. Right. Mhm. That's why this one's in the denominator as the answer. Mm-hmm. Yeah. We can do another. Last one, then let's get into the lesson. Wait, one second, one second. Got it? All right. Got it. As long as it isn't like B or G, but or G in like question 4.
It was one that you.
Yeah. Nah, it's not a typo. It's just that we're not doing that. Yeah. Yeah. It was crazy. All right, you up. That's it. Sean.
AB,
AD, like,
AB,
oh, AB.
and B over
Like this?
divide two over A to the second power,
Mm-hmm.
positive 7 over B.
All right, not bad, right? So before I could even do this, right, I have to get the numerator to look like a fraction and the denominator to look like a fraction, right? Then I could do keep, change, flip, simplify, all that good stuff.
So would be
Mhm. Well, first for the top, what's the LCD? That's a part of it. What else?
AB squared.
AB squared, right? So that's my LCD. AB squared. So now the first one is an A and a B, so it's missing what? Right, so it's missing a B, right? So I'm gonna multiply this by B, but what I do to the bottom, I do the top. Over here, I have B squared, so I'm missing what? A, right? So I multiply this by A, but what I do to the bottom, it's the top. Because there's two B's, right? B squared is the LCD. Yeah, so it's missing just one little B, right? Yeah. So that being said, let's put this all together. What do I have? I have 7B minus 3A over AB squared. Now I'm in the denominator, right? For the denominator, what's the LCD? A squared, B squared, right? So now I have an A squared in this one. I want to multiply this by what to get A squared, B squared, by B squared, right? But what I do to the bottom, I got to do to the top. Over here, I have B squared. I want to get that to look like A squared, B squared. So what do I have to multiply this by? By A squared, right? What I do to the bottom, I do to the top. So let's put this all together real quick, right? So what do I have? I have 2B squared plus 7A squared, all divided by A squared, B squared. And then that's it, right? Right, now we're gonna do keep, change, flip. So in keep, change, flip, I'm gonna keep the numerator, 7B minus 3A over AB squared. Now I'm gonna flip the denominator and change this to multiplication. So multiplication, then a squared, b squared over two b squared plus seven a squared. Right? At that point now, nothing else left to factor, cross out the like terms, right? So what are my like terms here? Okay, so I heard the A and then the B to the second, right? Mm-hmm. So now, final answer we're gonna have here, right? This is gonna be A times seven B minus three A, all divided by two B squared plus seven A squared.
Oh, yes, I was wondering why you didn't cross out those pieces, but it's not here.
Right. Mm-hmm. Questions on that? Hmm? Right.
So that's for addition to.
It's just for multiplication and division. But this was division, actually. Yeah.
Have to do that, well, the LCD.
Mhm. LCD is only for addition subtraction.
Oh.
Yeah. So individually, the numerator and the denominator, we have to do that. But not in the end, though.
Did that for a lot of problems.
You probably got it right there.
Yeah. Other more ways.
One, yeah. All right, let's look at today's lesson real quick. It's gonna be a short lesson. As I said, y'all probably know how to do it all already. But before we go into the lesson, you know, I like to start with a little blast from the past real quick. So help me out. How do I do this? X to the 5. Very good. How'd you get that? You subtract the powers, right? So this becomes x to the 9 minus 4 power. Very good. All right. How about this one? Oh, it's gonna get somebody. I don't know who, but it's gonna get somebody. Next exam though. What about this one? Y to the 7? No. Y to the no. -8, yeah. All right.
Oh, wait.
Why did they
Put up
do
bracket.
All right. Because you do top minus bottom, right? So it becomes y to the 3 minus 11, -8, right? But as you were saying, though, right, it's illegal for me to have negative powers, right? So this goes down into the denominator and becomes y to the 8 like this. So this is my final answer, right? Can't have negative exponents, right? Little blast from the past. Nah. Next test, yeah. All right, this one now. It's a hard one right here. What's the answer? Hmm.
Oh,
Yeah. Into the 12 power, right? So whenever we raise a power to a power, we multiply, right? This becomes n to the 2 times 6 power, right? Yeah. Little blast from the past. N squared 6 times. So that's how you get the 12. Right. Yeah. You could do it that way too. Yeah, that's legal too. Yeah. Right. Yeah, that's legal also. So this is called simplifying radical expressions. All right, so we use the product property to simplify radical expressions. So we will simplify radical expressions in a way similar to how we simplified fractions. A fraction is simplified if there are no common factors in the numerator and the denominator. To simplify a fraction, we look for any common factors in the numerator and denominator. A radical expression, such as the nth root of a, right, is considered simplified if it has no factors of m to the n power. So to simplify a radical expression, we look for any factors in the radicand that are powers of the index. All right? Real important there. Write that down somewhere. All right? So simplified radical expression, right? So for real numbers, a and m and n, which is greater than or equal to 2, the nth root of a is considered simplified if a has no factors of m to the n. All right? Make sense? All right, somebody needs to hear it a third time. I got you. No problem. All right? Y'all know I like to repeat myself. Oh, shoot. It's not listening to me. Be like that. Still not listening to me. Yo, for real. I just off my add questions to the test, yo. Like, maybe. Next test, I got you. So for example, the square root of 5 is considered simplified because there are no perfect square factors in 5, but the square root of 12 is not simplified because 12 has a perfect square factor of 4. Similarly, the cube root of 4 is simplified because there are no perfect cube factors in 4, but the cube root of 24 is not simplified because 24 has a perfect cube factor of 8, right? So to simplify radical expressions, we will also use some properties of roots. So the properties we will use to simplify radical expressions are similar to the properties of exponents. We know that a times b to the n power is equal to a to the n times b to the n. The corresponding of a product property of roots says that the nth root of a times b is equal to the nth root of a times the nth root of b. This is really important. Remember that. It's an important fact right there.
I don't feel it.
You don't?
What
Got
does that
to.
mean? You gotta separate them?
Exactly. Yeah. When you look at the example, it'll make more sense. All right? So product property of nth roots, right? If the nth root of a and the nth root of b are real numbers, and n is greater than or equal to 2 is an integer, then the nth root of a times b is equal to the nth root of a times the nth root of b. And reverse. Nth root of a times the nth root of b is equal to the nth root of a times b. All right, let's look at an example real quick.
Where the n is,
That's the index number.
inside of it.
The radicand. So let's take a look at an example, right? Let's say I was asked to simplify 98, right? So I want to know, is there a perfect, in this case, square that goes into 98? What do we think? There is. 49, right? Right, so we look for a perfect square that goes into 98. In this case, it's 49, right? Because square root 98 could get broken down into what? Square root 49 times square root 2, right? And then help me out. What's the square root of 49? 7. So this is my final answer. 7 square root 2.
Okay, I got that. I
Yeah.
use 49.
Yeah. So it don't matter, right? So that's what we're doing here, right? We're looking for the perfect whatever the index is, that goes into the radicand, breaking them apart, then simplifying it. Right?
How do you get that?
49?
Yeah.
Yeah. You could do it like that. Just divide out prime numbers and see what happens. Or you could break it all down into prime numbers and you'll see a repeat. Go ahead. Go ahead, Theo. You can see. Because 49 times 2 is a 98. Yeah. But they both have the square root though. Yeah. You guys try. Here's one. It's not as hard as that one, but still pretty good. Square root of 48. What do we think? 24, no. Is there a perfect square that goes into 24? I mean 48? That's a good, but it's something, I need something better. No. Yeah,
Yeah, 4 and 3. I don't know.
nah. It's not that.
Oh, yeah, that's just 12. 1 here.
Mhm. It's okay. Maybe this will help you see it, right? Start with the tree. We have 48, right? So I think you said what, 12 and 4? Start with that. So 12 times 4 is 48. Keep breaking it down, right? 12 is what? 6 and 2. Okay, 2 is prime. And 4 is 2 and 2. That's prime. That's prime. Break down to 6. What's that? 3 and 2, right? Prime, prime, right? So, you know that square root 48 is like it's like a 2 index, right? For 48, right? So I want a number that's going to be divisible by 2, right? If I take these 2's here, multiply them all together, what do I get? 16, right? That's what it is. So square root 16 times square root 3. And then the square root of 16 is, no, it's 4, right? Oh, wait, 4 square root 3, yeah. That's my answer.
There's a way to get the
Mhm.
other breakdown from the calculator.
Mhm. Another way you could do this too, you see how I have 1, 2, 3, 4 2's here? And I have 1, 3. You can actually rewrite this as the square root of 2 to the 4 power times 3, right? 3 to the 1, right? Now, right. So, sorry? Just for your knowledge, you're right. The 2 doesn't need to be there. If it's blank like that, it means square root. Yeah. So what you could do, right? At this point, you could say square root 2 to the 4, square root 3, and then the square root and the 4 will reduce. They reduce like this. This becomes 2 to the 4 power over 2. We didn't talk about that yet, but that's coming up, right? So the power on the radicand is the numerator, and the index is the denominator. And 4 divided by 2, what's that? That's 2, right? And then what does that become? 4 square root 3. That's another way to do it.
That one was a little bit extra.
It was. To be honest with you, the second way, that's actually how I do it. Because I don't know if I told y'all this, but I don't know my timetables. So I just count, right? So that's my secret. I use that way. I just count the way. Right. Mm-hmm.
Right.
Because 24 is not a perfect square. No, yeah, it has to get broken down. So yeah, oh yeah, we got more coming. Yeah, perfect square. So look, notice in the previous example, right, that we simplify that the simplified form of square root 98 is 7 square root 2, which is the product of an integer and a square root. We will always write the integer in front of the square root. Be careful to write your integer so that it is not confused with the index, because the expression 7 square root 2 is very different from the 7th root of 2. See that? Yeah. Because this one is 7 times square root 2, but this one is a 7th root of 2. Completely different numbers. Like 2 to the 1/7 power. That's what that's saying. That's what the second one's saying. The 7th root, yeah. It's something different though. It's a crazy decimal, you're right. It's a crazy, crazy decimal. All right, so here's a little bit of procedure real quick. What we're doing. Some notes if you want to write them down. So simplify a radical expression using the product property. Step 1, find the largest factor in the radicand that is a perfect power of the index. Rewrite the radicand as a product of the two factors using that factor. Step 2, use the product rule to rewrite the radical as a product of two radicals. Step 3, simplify the roots of the perfect power. And that's it. That's how we simplify the radicals. All right, we'll try another one. It's not. Nah, it has to be a perfect square. So the right perfect square for that would have been 16. Because then the square root of 16, that's 4. How about this? Let's try this one out. All right. So I got 500 here. What's a perfect square? 105. That's what I'm talking about right there, right? So this is square root 100 times square root 5. And what's the square root of 100? So 10 square root 5. That's my answer. I'm done. That's simple. All right. What about B? What do you think about B? So what's the perfect cube that goes into 16? What is it? Cube. A 6. What is it? Not 4. What is it? What do you think it is? Not 2. Well, 2 times what?
Oh, okay, so it has to be
8, right? So it's cube root of 8 times cube root of 2, right? And what's the cube root of 8? Not 4. 2, right? So final answer, 2 cube root of 2. Yeah, it stays a cube, it's cube root. All right. Cube root of 8 is just, it did? It's just the same number 3 times. Yeah. So I need one number to go into it 3 times, and then the other number can go in as many times as it wants. Something like that.
I got a question. What do we need
This?
Like actually.
Measuring?
Really?
Yes. I gotta think about this one. That's a good question though. I gotta think about this one. Normally I have an answer for everything. But this one, that's a good question. What about C? What do you think? Mm-hmm. I'm about to try and figure this out with y'all because I don't even know. So I'm gonna give you a hint though, right? Let me see. 2 plus 4 is 6, right? Plus 3 is 9, right? 9 is divisible by 3, right? So this thing is divisible by 3. Hmm? 81 and 3? Okay. So I heard 81 and 3. So what's the fourth root of 81? Mhm. 3. So that's the answer. 3, fourth root of 3. Very good. All right. So look, if it looks real crazy, just go straight to the tree. Just count your way out of it. All right. That's what I was about to do, right? So when I saw 2 plus 4 plus 3 is 9, and 9 is divisible by 3, right off the bat, I was about to just do 243. It's broken down into two numbers, 3 and 81. 3 is prime, so I'm done with that. Now I would have just kept breaking this down. 9 and 9, 3 and 3, and 3 and 3, right? How many threes do I have here? 1, 2, 3, 4, 5 of them, right? So I have the fourth root, right? I need one of them to be divisible by the index, right? So I have 3 to the 4 times 3 to the 1, right? The 4 times the 1, that's going to be the 5, right? And when we multiply the powers, we add them, right? So now this fourth one, that one will cancel out the fourth root. And then this lone one will be stuck underneath there, right? So then that's the 3, fourth root of 3. That's my way of doing it.
Just like write the answer if you can have a problem.
Sure. You have to know it.
Just like success your factorization skills.
Yeah. Go ahead. For B. So, well, no, six times 3?
Yes, that's 18.
But that's 18 though. Yeah, it gotta be 16. Yeah. So 8 is a perfect cube, right? But same thing as what I was saying with C. I mean, excuse me, with C, right? If it looks a little confusing to do, right? Do the tree. The tree will never fail you, right? 16 is what? 4 and 4. And then hold on one second, let me just scroll down a little bit. And then this is 2, 2, and then 2 and 2, right? So I have 4 2s. So if I want to do the cube root of 2 to the 4 power, I need to break it apart so that one part is divisible by the index and one part isn't. So cube root 2 to the 3rd times cube root 2 to the 1. These will cancel out. And when these cancel out, this becomes what? 2 cube root of 2. That's the easier way to do it. Just count your way out of it. You know? Otherwise, find the perfect index that goes into it, and then that's it. All right. Any questions on this? All right.
I guess word.
Yeah. I guess we could cut it short right here, and then we could take the test. If y'all want to like use the bathroom or something, go ahead and come back. Yeah.
That's what we're on.
Is it what? Sure.
So it is.
I didn't even post this one yet.
Did it?
No, I'm about to do it. I'm about to do it right now, though.
Cause I know it, but then right here.
Nah, that's real, right? So
Yeah,
it's
but-
that is negative
Eight.
what?
9.
Oh,
Not -9?
no. It's negative, but what number raised to the fourth power is 81? Yes,
Okay. So it's the- Three?
three, not three. Yeah, three. You just put -3 and that's it.
So how is that? 3?
Because the fourth root of 81 is 3, and then you just put a negative next to it. It's when the negative is in the radicand that it's not.
But then I know that it's like. It turns it, when, you're gonna teach them, it turns
Yeah.
into positive.
Which one?
That.
The answer?
Inside. Oh, that's when the inside is negative.
Yeah.
That it
If the
does-
inside is negative and the index is even, that's not real.
Okay.
Yeah, but if the outside is negative, that don't matter. Yeah. Alright, everybody done copying? I can take this down? So yeah, just want to get it on the recording, right? Tomorrow's pantry. So make sure y'all bring y'all carts and everything, get y'all free groceries. Yippee, right? Yesterday's announcement has the link to sign up if you've never done it before. Just fill that out, go there, grab your stuff, be happy. All right? We'll post this homework right now. So if we good, I'm gonna take this down. Spin real. Do, 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 do.